Hello there, and today we're going to start on an entirely new topic. We're going to have a look at organic chemistry as a whole, and that's going to be for the next 4, 5, 6 lessons. We're going to start off with the basics, and we're going to build on there. Going to use a lot of new terminology, so when you're making notes, feel free to pause the video as and when you need to, so that you can write those keywords down. You can get the definitions written in, because we'll be coming back to them again and again. I'll also tell you at points to pause the video, because then you can do the questions, have a go at them, and then check your answers on the following slide. But rather than just blasting through the whole video, take the time, pause it as and when you need to, and when I say to, so that you can get the most out of it. So today, really going to be covering 3 things. Introduction to organic chemistry, alkanes. I'm going to say what they are, name them, and draw them. I'm going to describe how alkanes are formed, and we're going to say how they can be obtained. So, first and foremost, what are alkanes? Alkanes are hydrocarbons, compounds made of only carbon and hydrogen. I've put those in bold because I think they're key words, something that you probably will want to make note of. So, for example, we've got methane, a carbon, and hydrogens. We've got ethane, 2 carbons, hydrogens, and propane, 3 carbons and hydrogens. Notice it's only carbons and hydrogens, which is why we can refer to it as a hydrocarbon. All alkanes are saturated. That means that all of the carbons, apart from methane here, are connected by a single covalent bond. So between these 2 carbons, single covalent bonds. Between these 2 carbons, single covalent bonds. Between these 2 carbons, single covalent bond. Because there are only carbon-carbon single bonds, we would describe it as saturated. All alkanes have similar properties, but they'll differ by the number of carbon and hydrogen atoms. They form something called a homologous series. That's the family name for a type of compounds. They all have similar sort of features. They react in similar ways, but they only differ by the number of carbons. So all of these guys up here are part of the homologous series of alkanes, because they've got carbon and hydrogens and only carbon-carbon single bonds. They all have the same general formula. So that means the number of carbons in relation to the number of hydrogens is the same for all of them. We're going to come on to that in a little bit. Why and what that formula is. So how do we name them? I've already given you the names for 3. Could you see any pattern between methane, ethane, and propane? Is there any commonality? There we go. All alkanes end in ane, but the first part of the name is determined by the number of carbons, or you can look at it in reverse. The first part of the name tells you how many carbons there are in that compound. So, for example, methane, the meth refers to the fact that there is 1 carbon. Eth refers to the fact that there are 2 carbons in the chain, and the ane tells us that it's an alkane, so only carbon-carbon single bonds. Prop, that tells us that there are 3 carbons in the chain, and ane tells us that it's an alkane, so there are only carbon-carbon single bonds. And butane, there are 4. 1, 2, 3, 4. Now, for the first bit of the interactive elements of this lesson, what are the names of the following shapes? Pause the video, give yourself a bit of a chance. Can you name them? Welcome back. What do you think the names of the alkanes that contain 5 to 10 carbons are going to be then? There's a bit of a link going on here. Pause the video, see if you can name them. If you're feeling really fancy, you can even try and draw them. and welcome back. So those of you that had a go at drawing them, the way that we've drawn them here, is called a displayed formula, and it's displaying all of the atoms and all of the bonds within the molecule. So you can see very clearly where those atoms are and what they are bonded to. Cool. So what I would like you guys to do now is, in your notes, draw out a table. You don't have to do a table. You can do it as bullet pointed off, number of carbons, 1, methane, display formula, and then write out its general formula. So if we're writing out the general formula, for example, methane would be CH4. If we're writing out the formula for ethane, it would be C2H6. Propane, C3H8. Butane, C4H10. Now, you only really need to know the names of the first 4. I would say make sure that you're familiar with the names of the first 10. The first 4 are the more difficult, 5, 6, 7, 8, 9, and 10. That's based on shapes that you've done in maths, so you should find that easy. There is a general formula that describes the relationships. And what I'd like you to do is pause the video now, have a go at doing the table, complete the first 4 display formulas, and then do the formulas for the first 10, and then see if you can have a go at doing the general formula for alkanes. Cool. And welcome back. So far we have covered the first part of the lesson. Name and draw the structures of alkanes. Pretty quick. Now we're going to talk about how they are formed. That's a bit of time for a story time. So, is that ready? Nice and quiet. Right, off we go. I'm going to take you back in time. Back not just a few years, not just a few hundred years, nor a few thousand. We are going back hundreds of millions of years, about 300 million years ago, to a beautiful tropical time with dinosaurs. Now that could be on the land or in the ocean, but over time, as those animals died, now in the oceans, they'll get covered up by sediment. On land, the layers of organic matter build up over time. And sediment builds up and the animals get covered. And there's a specific condition that they're now under. It's called anoxic, which means that there's no oxygen present, or very, very little. And combine that with heat and pressure over millions of years, the lack of oxygen, the heat, and the pressure cause the organic matter, all of this skin and the proteins and the cells, to change into hydrocarbons. And as they're turning and changing into hydrocarbons, they form something called crude oil. Now, if you want to watch a bit of a video on that, there's quite a nice animated one on YouTube. You can click into the link on the PowerPoint, or you can go to the link on YouTube, either which way. So it tells you a bit about fossil fuels, tells you how they formed, and there's also a bit more of additional information on the different types of fossil fuels, which we don't really cover on this course, but it's just interesting, it's good to know. So we've covered a few words. We've got fossil fuels, non-renewable. If it takes hundreds of millions of years to form, yes, we can renew it over time, but not in our lifetime. So we class it as non-renewable because it's very, very hard to regenerate them. We've said about crude oil forming hydrocarbon compounds, and it's a mixture of lots of different types of them. We've got them buried underneath silts. We've got the anoxic conditions and heat and pressure. And what I would like you to do is use the below bullet points to write a paragraph in your book. You may use bullet points if you wish to summarize how crude oil is formed and what it is. All right, pause the video off you go. This tends to be a 6-mark question, so give yourself about 6 to 10 minutes to do it. And the answers. So here's an example paragraph that we've got typed up. What I'd like you to do is read through your answer, read through this answer. This is typically looking at a full 6 marks. What I'd like you to do is use the ladder on the side. Where do you think you fell? And be honest with yourself. Do you think you did well? Are you looking at more that 5, 6 marks? Were you okay? Did you get most of the keywords in? Or do you think you didn't do particularly well? If you're looking at this whole region, 1 mark up to 4, if you don't think you did very well, what I'd like you to do is pick out the points that you've missed from in here, and red or green pen, or even just a different coloured pen, add those into your answer. So we know what alkanes are, we know how to name them, we know how to draw them, we can describe how they are formed. Now we're going to have a very quick look at how they are obtained. And this is great because for you guys, it's looking back to what we did at the start of year 9 and talking a bit more and elaborating on fractional distillation, which is great. We're just linking back all of that information to stuff that we've done before. So how do we obtain alkanes from crude oil, which we know is a mixture of different hydrocarbons? So as we go down the table from methane to decane, something happens to the boiling point. It goes from minus 162 all the way up to 174. Melting points and boiling points will gradually increase as we go down the table. It's because between molecules there exist intermolecular forces. Now, the more intermolecular forces there are, or the stronger those intermolecular forces, the harder it is to break molecules away from each other. So in gases, the intermolecular forces are weak. So they're not strongly attracted to each other. So the gases are free to move away and disperse. In solids, they are really, really strong. And so it's very difficult for us to break those molecules apart from each other. As we go down the group, boiling point and melting point increase. But what else changes as we go down the group? For those of you that said the size of the hydrocarbons or the number of carbons and hydrogens present in the molecule, you're absolutely spot on. Give yourself a round of applause and a pat on the back. Good job. The larger the molecule, the more points of contact, keyword, and therefore more intermolecular forces, and so more difficult to break apart. Smaller molecules, less points of contact, less intermolecular forces, easier to break them apart. We're going to move that on to fractional distillation, where we put in crude oil at the bottom, we heat it up to a nice high temperature. Most of the gases will then, or most of the alkanes will vaporize, they'll turn into a gas, they'll boil away, and the hot gases will start to rise. And when they get to a point where the level is below their boiling point, they'll condense and turn it into a liquid, and they can be collected off. So at the very top, there are the smallest molecules. So all of the molecules that fall under the propane fraction, the mixture of different alkanes that are in the naphtha fraction, the different alkanes in the diesel fraction, and then we've got down at the largest molecules, we've got really big molecules in the fuel oil fraction. Up at the top, we've got the small molecules, so they've got short or small chain alkanes. There are fewer intermolecular forces, less energy is required to separate the molecules from each other, and so they have a low boiling point. Down at the very bottom, where we've got the really large molecules, the long chain alkanes, the ones with more carbons and hydrogens in them, they've got lots of intermolecular forces, lots of points of contact between molecules. and therefore that will require more energy to separate the molecules from each other, and it will have a high boiling point. I want you to make special note of these because these are key points, key marking points when you get asked about why crude oil can be, or how crude oil can be separated in the exam. They're looking for these points using these key terms. And that's us done. That's the lesson finished. Now, I appreciate you'll probably want to go back over it, have a look at some slides. You can pause it, rerun it, go over it again. Make sure that your notes are nice and detailed. Use diagrams. That's why we've got the diagrams in there. That's why we've included them, so that you can add detail to your notes. Now, if you'd like, as a way of learning to revise, looking at different techniques and different methods, optional homework is a revision strategy. It's called Cornell Notes. On an A4 sheet or in your book, you're going to split it down into 3 sections. Margin, I'd say about twice the width of the current margin that you've got in your books. 4 or 5 lines at the bottom of the page, and then a big section in the middle. Now, this bit over here, that's for keywords, key points, or definitions. Small, pithy little bits that, keyword, I've not come across this before, I'm going to write that in. The main area, that's for your diagrams, that's for sentences, for paragraphs, for your main body of text, your main note-taking, and then at the bottom, we're going to try and summarize everything into 2 to 4 sentences. Now, that's the challenge. As you're making your notes, you're thinking about the context of all the content, and then when you're down at the bottom, you're having to think about it again. And by forcing yourself to think about the content in lots of different ways, you're going to make sure that your brain is processing it and more likely to remember it later on down the line. However, if you don't have a go at this, then no worries. Just make sure that your notes are as detailed as possible. And if you want to really challenge yourself, try and do it all from memory. And then you can add bits in as you go back and check it. Excellent. Hope you found that helpful. Hopefully see you soon.